All right, let's look at lesson 6.02, which is about trapezoids. So we'll start with the definition of a trapezoid. A trapezoid is a quadrilateral, excuse me, a quadrilateral with two parallel sides. So in this case, AD is parallel to BC. Then we have this special one, an isosceles trapezoid. This is a quadrilateral with two parallel sides and congruent legs. So the legs on an isosceles trapezoid are here. You see that the legs are not parallel to each other. And I should add that the parallel sides of a trapezoid are called bases. So this is a base, this is a base. Because we have congruent legs on an isosceles trapezoid, we also get some congruent angles. So we get base angles congruent. So angle B is congruent to angle C, and angle A is congruent to angle D. That's on an isosceles trapezoid. On some regular trapezoid, or irregular trapezoid, I guess we might say, we don't know if there are any congruent angles. In both cases, because they are quadrilaterals, the total of all the angles is 360. Okay, so now let's look at trapezoids that are not isosceles. So they do not have rotational or reflective symmetry. The sides, we have two parallel sides called bases. So in this case, we would say that segment AD is parallel to segment BC. Then the angles, the adjacent angles on each leg, again, these are legs, are supplementary. So that means angle A plus angle B equals 180 degrees. And that also means that angle D plus angle C equals 180 degrees. The diagonals, so from A to C and from B to D, are not congruent. So the only things that we know that really are definitely true for a regular trapezoid are that the bases are parallel and that the angles that are adjacent to each other on each leg are supplementary. So B plus A equals 180 and C plus D equals 180. Okay, now we'll look again at isosceles trapezoids. So isosceles trapezoids do have some symmetry. They map onto themselves after a reflection, after a flip, across the bisector of both bases. So if I can find the midpoint of AD and the midpoint of BC, then I get reflection across that line. So the sides of an isosceles trapezoid, one pair of opposite sides, the bases, are parallel. That's AD parallel to BC. AD parallel to BC. And then we also get, so that's parallel. Let's see. And then we also get, because we're isosceles, we get sides that are congruent to each other, the legs. So we have one pair of congruent legs. This is AB, is congruent to DC. Now we'll look at the angles. So in an isosceles trapezoid, the base angles are congruent. So angle B congruent to angle C, and also angle A congruent to angle D. Then, as we said, adjacent angles along the legs are supplementary. So angle A plus angle B equals 180 degrees, and angle C plus angle D equals 180 degrees. Then, special for an isosceles trapezoid is that opposite angles are also supplementary. So you see B and A are supplementary, but then C is congruent to B. So we could use C instead of B and say C and A are supplementary. And angle B plus angle D also equal to 180 degrees. All right. One more thing that we need to talk about is the diagonals. So before I turn the page, I just want you to see that the diagonal BD is congruent to the diagonal AC. So AD congruent to BC, diagonals congruent. I'm going to turn the page back again. And the pieces of those diagonals are also congruent. So if I can sketch this correctly, from B to D, let's try that again. From A to C. So the pieces of the diagonals are also congruent. So what I mean is that if this is point E, then BE is congruent to CE, and AE is congruent to DE. AE congruent to DE, and BE congruent to CE. All right, let's work an example problem. This problem tells me that I have an isosceles trapezoid. So the isosceles trapezoid has congruent legs, and it has congruent base angles. So angle B congruent to angle C, angle A congruent to angle D. Now we have some information. Angle ABC, 5x minus 40. This is the angle. I just don't want to write over my annotation. And angle DCB, x plus 40. Right here. So I've already marked these as congruent. So that means that in an equation, these expressions should be equal to each other. So we have 5x minus 40 equals x plus 40, and solve for x. Subtract x from both sides, add 40 to both sides. Get 4x equals 80. Then divide both sides by 4. And get x equals 20. Now from there, what property of isosceles trapezoid justifies my equation? So the answer here is that angle B is congruent to angle C. And those are called base angles. Base angles of isosceles trapezoid are congruent. Then it says find the measure of all 4 angles above. Okay, so we know x equals 20 in this situation. So I can substitute 20 here, and I'll say 5 times 20 is 100. 100 minus 40 is 60. So that gives me angle B equals 60 degrees. And that gives me angle C also equals 60 degrees. We mark those as congruent. We said that angle A and angle B are supplementary, so they add to equal 180. So 60 plus something equals 180. That something is 120. Angle A is 120 degrees. And then angle D is also 120 degrees. You can see that it's marked congruent to angle A. So they're both 120 degrees. All right. We'll move into you do round 1. In an isosceles trapezoid, so again, it's special, it's isosceles. So we have legs are congruent. We have base angles congruent. And we're given angle A is 135. AB, this is not an angle. AB is a length of 5x minus 5. I'm going to write that in a different color. AD, here, AD, no, sorry, AD is here, AD, 5x, and then DC, x plus 15. So now I want to think about, well, what else do I know? And I know that if angle A is 135 degrees and angle D is congruent to angle A, then angle D is also 135. Then we know that these angles are supplementary to each other. So 135 plus angle B equals 180. That means that angle B is 45 degrees. And since angle C is congruent to angle B, then this is also 45 degrees. Now, set up an equation to solve for x. So we have 5x minus 5, 5x, and x plus 15. What we know is that the legs of an isosceles triangle are congruent. So since they're marked congruent, I should set these equal to each other. 5x minus 5 equals x plus 15. And the reason I can write that equation is because the legs of an isosceles trapezoid are congruent. Now solve for x. So we will subtract x from both sides, add 5 to both sides, and there we get 4x equals 20. Again, divide by 4, get x equals 5. Fill in all angle measures of the trapezoid. We already did that. Then finally determine the perimeter of the isosceles trapezoid. Oh, I forgot to annotate something, which was BC. BC 2x plus 30. So I'll put that down here. All right, so we know x equals 5. So if x equals 5, then AB equals, so we have 25 minus 5 is 20. We have AD is 5x, so that's 5 times 5 is 25. We have BC is x plus 15, so 5 plus 15 is 20. And that should make sense because AB and BC need to be the same length when it is an isosceles trapezoid. And then finally BC, 2x plus 30, so that's 10 plus 30 is 40. Now to find perimeter, we need to add all of them together. So there we get 40 and 20 is 60, 60 and 20 is 80, 80 and 25 is 105, and we'll call these units because they did not tell us in the problem what the units were. Finally, now we have an example where our trapezoid has diagonals. And again, so let's see what they give us here. I think that we need to say that this is an isosceles trapezoid, but let me have a look at it real quick. So we have segment TA is 60x plus 16, and we have segment PR is 30x plus 46. So in order for us to know the relationship here, we do need to say that this is an isosceles trapezoid. So to determine the value of x, I can say TA is equal to RP. The reason I can say that is because isosceles trapezoid has congruent diagonals. So now we'll substitute the expressions. So TA 60x plus 16, RP 30x plus 46, subtract 30x, subtract 16, and on this one we get 30x equals 46 minus 16 is 30. We divide both sides by 30 and get x equals 1. And there you've done it. So again, to review, if we're talking about any old trapezoid, we know that there is one pair of sides which are the bases that are parallel. And then we also know that the angles that are along the legs are supplementary. So A plus B is 180 and D plus C is 180. Then with an isosceles trapezoid, we know more. In an isosceles trapezoid, we know that we have congruent base angles, B congruent to C, A congruent to D. We also have congruent legs, AB congruent to DC. We know AD is parallel to BC, the bases are congruent. We know that it has reflective symmetry through a bisector here. And then finally, I wrote this on the whiteboard before, the diagonals of an isosceles trapezoid are congruent to each other. Great job.